Welcome, everyone, to TechDaily.ai. Today, we're taking a deep dive into, what promises to be the next major revolution in wireless connectivity, Wi-Fi 7. We're going to explore what it is, why it's poised to fundamentally change how you interact with your digital world, and crucially, what you need to understand to truly harness its immense potential. Now, this deep dive is sponsored by Stonefly. They're your trusted solution provider and advisor in enterprise storage, backup disaster recovery, hyper-converged VMware, Hyper-V, Proxmox clusters, AI servers, SA365, that's a turnkey security appliance, and public and private cloud solutions. For more info, you can explore stonefly.com. Okay, so imagine your digital life as this bustling superhighway, right? With previous Wi-Fi standards, we've had, well-paved lanes, but sometimes they get pretty congested. Now, picture a high-speed maglev train arriving. It promises unparalleled speed, efficiency, seamless connectivity. That's kind of like Wi-Fi 7. But just like that maglev, the infrastructure, the tracks themselves, they have to be meticulously designed and laid out for you to really experience its true power.
Precisely. Yeah, we're talking about the latest iteration of wireless technology. Officially, it's known as 802.11b, or you might hear it called extremely high throughput, EHT. And it's really not just an incremental upgrade. It's built from the ground up to deliver genuinely groundbreaking capacity and potential. It's ushering in what a lot of people are calling a new era of wireless networking.
So what exactly is Wi-Fi 7 then? And how does it stack up against, say, its predecessors like Wi-Fi 6E? Because honestly, for many of us, 6E still feels pretty new, maybe even overkill for what we need right now. What's the real differentiator here?
That's an excellent point, and it gets right to the core of this quantum leap idea. Wi-Fi 7 does operate on the same three bands as Wi-Fi 6E. So you've got the standard 2.4 gigahertz, the more common 5 gigahertz, and that newer, less congested 6 gigahertz band. However, that's pretty much where the significant similarities end. The key difference is just this monumental jump in capability. I mean, while Wi-Fi 6E, that topped out at a theoretical maximum speed of about 9.6 gigabits per second. Wi-Fi 7 boasts theoretical maximums of up to, an astonishing 46 gigabits per second.
Wow, 46? That's nearly 5 times faster. That number almost sounds, like marketing hype, doesn't it? Can you help put that into perspective? What kind of practical difference does that actually make for someone at home or maybe for a business today? Are we really seeing applications that need that kind of speed right now? Or is this more about, future-proofing our networks?
That's a very valid question. And the answer is kind of both.
Mm-hmm.
While your average web browsing or maybe even 4K streaming, that won't max out 46 Gbps on its own. But Wi-Fi 7 isn't just about raw speed for one device. It means 2.4 times the aggregate throughput compared to Wi-Fi 6E. And significantly reduced latency, a more consistent extended range, and overall greater reliability across your whole network. This power is essential for these emerging, incredibly data-hungry applications that are just hitting critical mass now. Think about it. Truly smooth, uncompressed 16K video streaming, real-time competitive gaming where every millisecond counts, right? Deeply immersive VR and AR experiences that demand near zero lag. Even things like professional music production where latency can just completely derail a session. It's specifically designed to keep pace with today's multi-gigabit internet plans too. Making sure your wireless connection doesn't become that hidden bottleneck for your broadband, it really future-proofs you for the truly connected home or office with dozens, maybe hundreds of smart devices all online.
Okay, so it's not just about making my laptop faster, but making the entire system, the whole ecosystem, hum along more efficiently, preventing those frustrating slowdowns when everyone's online. Yeah, got it. All right, let's unpack how Wi-Fi 7 manages this. How does it achieve these incredible speeds and promise such a transformative experience? What's the secret sauce here? Is there one single most innovative feature that truly redefines how devices connect?
That's a great way to put it. The engineering behind Wi-Fi 7 is quite ingenious. It's got several key innovations working together. If I had to pick one secret sauce, I'd probably lean towards multi-link operation, MLO. But let's look at the foundational elements first. They're all important. So first up, we have wider channels. Wi-Fi 7 doubles the available channel width to 320 megahertz, and that's specifically in the 6 gigahertz band compared to the 160 megahertz channels we had in Wi-Fi 6E. Then think of it like adding significantly more lanes to our digital superhighway. More lanes mean more data can flow comfortably, rapidly, reduces congestion, increases speed for everyone.
Double the width. Okay.
Second is higher QAM. It's 4096 QAM. Now, QAM stands for Quadrature Amplitude Modulation. Bit of a mouthful, but what it means is that Wi-Fi 7 supports this 4K QAM QAM, allowing each radio wave to pack in far more information. Technically, it's 12 bits per symbol versus 10 bits in Wi-Fi 6's ton 24 QAM. This seemingly small change, it alone increases data throughput by about 20%. It's like fitting more data into the same amount of transmission time makes the stream denser, more efficient.
Okay, you mentioned multi-link operation, MLO, as the potential game changer. That sounds like a really fundamental shift in how devices operate. Could you give us maybe a more tangible example? Like how might MLO save, say, a live streamer from a disastrous dropout?
Right.
Or genuinely enhance a VR experience beyond just raw speed?
Absolutely. Yeah, multi-link operation, or MLO, it fundamentally changes things. Previous Wi-Fi standards connected devices on, a single band at a time. Your router might intelligently choose the best available band, but only one. MLO, on the other hand, lets devices combine frequencies. They can send and receive data across multiple different bands simultaneously. So, for instance, using both the 5 GHz and the 6 GHz bands at the exact same time for a single connection.
Wow, okay, like 2 connections at once.
Exactly, or potentially even 3. So for that live streamer you mentioned, this is huge. If one band suddenly experiences a burst of interference or gets congested, the other band just seamlessly picks up the slack. It maintains that consistent, low-latency connection. No more sudden pixelation or dropped frames. For VR, it means the headset can constantly optimize its connection, ensuring head movements translate to visual changes with virtually no perceptible lag. That really deepens the immersion. It's kind of like having multiple backup internet connections active simultaneously, but all working together for one device.
That makes a lot of sense.
Then we have something called preamble puncturing. Now imagine you have a nice wide channel available, right? But a small, isolated part of it is blocked. Maybe interference from a neighbor's network, or even a dodgy microwave oven. With older Wi-Fi, that interference, even if it was small, could make the entire wide channel unusable. Just shut it down. Wi-Fi 7's preamble puncturing can essentially slice off or puncture that interfered part. It blanks just the problem area, allowing the rest of the channel to stay usable for data. So it's like a really smart traffic cop for your Wi-Fi, telling that noisy neighbor signal to stay in its lane without blocking yours.
Yeah, I think we could all use it, especially in crowded apartment buildings.
Definitely. We also see Enhanced MU Memo. Stands for Multi-User, Multiple Input, Multiple Output. Wi-Fi 7 supports up to 16 by 16, which doubles the 8 by 8 capacity of Wi-Fi 6E. This just means even more efficient data transmission to an even larger number of devices simultaneously. Think of a busy office. Everyone on video calls MU MIMO, helps ensure everyone gets their fair share of bandwidth consistently.
More simultaneous streams, basically.
Right. And finally, there's target wait time, or TWT. This feature, it was run before, but it's significantly enhanced in Wi-Fi 7. It allows devices to schedule their wake times. They can effectively sleep when not actively transmitting data, then wake up precisely when it's their turn. This dramatically improves power efficiency, which is especially beneficial for all those battery-powered IoT devices scattered around your smart home or business. Extends their battery life significantly.
So, for you, the listener, putting it all together, this really means a more seamless digital life. Imagine like 8K streaming without a single buffering wheel. Crystal clear video conferencing whether you're at home or maybe in a busy coffee shop. Ultra-responsive VR and AR that feel genuinely real. An end to those frustrating glitches and lag spikes. It's really tailor-made for our increasingly connected homes and the ever-growing Internet of Things. Where everything from your smart thermostat to your security cameras and smart appliances are all trying to talk online at the same time. Now, while Wi-Fi 7 clearly offers incredible advancements, deploying it, well, it sounds like it isn't as simple as just plugging in a new router and expecting magic. What are some of those critical mistakes people or businesses should be aware of to truly unlock its potential and avoid some common pitfalls?
That's a crucial insight. Yeah, the powerful capabilities of Wi-Fi 7 also demand more thoughtful implementation. It's not quite plug and play for optimal results. One of the biggest mistakes we see is simply a lack of proper planning. Many organizations, even individuals sometimes, just jump in without doing a proper site survey. It's really vital to use tools, maybe like heat mapping software, to predict the optimal placement for your access points. You have to consider things like construction materials, drywall versus concrete makes a huge difference. Potential interference sources, the density of users and devices in different areas. Getting professional design assistance here can really make all the difference. It ensures you don't waste the technology's potential by just sticking APs wherever is convenient.
Right. Planning matters more than ever.
Another common oversight is underestimating power requirements. These new Wi-Fi 7 access points, they can be pretty power hungry compared to older models. Think of it like trying to run a high-performance gaming PC on a basic laptop charger. It might power on, but you're definitely not going to get peak performance right. If you underestimate the power needs, it can lead to performance issues, instability, maybe even random outages. You really need to consult with experts or at least check the specs carefully and meticulously plan your power over Ethernet. That's PoE budget. Make sure your switches can deliver enough juice consistently. We've definitely seen clients wondering why their super fast Wi-Fi 7 wasn't living up to the hype, only to find out their PoE budget was barely enough for, say, Wi-Fi 5 devices.
The power draw. That's a sneaky one.
It really is, and you simply cannot neglect your wired infrastructure. Your super fast wireless network is only as strong as the cables connecting it all together. You absolutely must look at upgrading your Ethernet cabling. We're talking Cat 6? Ideally Cat 6A, or even Cat 7 for future-proofing. And make sure your switches and your router can actually handle the increased traffic and speeds that Wi-Fi 7 will generate. Skimping on the wired side creates an immediate bottleneck that prevents you from ever seeing those multi-gigabit wireless speeds. It's like having a Ferrari stuck on a gravel road.
That's a powerful analogy, the gravel driveway of a slow-wired backbone. Okay, but what about directing traffic on this new superhighway? What about managing these different frequency lanes?
You've hit on another key point. Yeah, another mistake is misunderstanding the Wi-Fi bands. The new 6 gigahertz band is super fast, absolutely, but it has a shorter range, and it's more easily blocked by walls or even furniture. The old 2.4 gigahertz band, while slower, has much better range and penetrates obstacles better. So it's still ideal for certain things, like maybe IoT devices far from the router. And 5 gigahertz is that versatile middle ground. So educating users or configuring the network smartly to use the right band for the right application helps optimize everything. Like maybe use 6 gigahertz for your VR headset in the same room, but stick that smart thermostat on 2.4 gigahertz.
Makes sense. Use the right tool for the job.
Exactly. Then there's improper channel management and maybe inefficient use of those wide channels. Features like channel bonding, using those wide 320 megahertz channels, are powerful, but if they're misunderstood or poorly configured, they can actually cause significant interference, especially in dense environments. Even with preamble puncturing helping out, thoughtful management is still key. You ideally want to use automated management software, something that can intelligently adjust channel widths and steer clear of already congested areas to maintain peak performance.
So automation can help there.
It can, yeah. And finally, and this really applies to any complex network, not just Wi-Fi 7, is simply poor network management overall. Even if you have the absolute best hardware, a poorly managed network will fail to deliver on its promise. It's essential to implement centralized management systems if possible, monitor performance regularly, don't just set it and forget it, and ensure your IT staff, or you if you're managing it yourself, are properly trained to manage and troubleshoot these advanced networks effectively. Proactive monitoring helps you catch small problems before they become big headaches.
Right. These proactive steps sound absolutely crucial then to turn a Wi-Fi 7 implementation into a genuine success, whether that's for your home or your business. It really does sound like a holistic approach is needed. Okay, shifting gears slightly. Beyond just speed and efficiency, what about security? Are there new security implications or maybe mandates that Wi-Fi 7 brings to the table that listeners should be aware of?
That's a great question, and yeah, it's something people are rightly concerned about. Now, while the 802.11bb standard itself doesn't directly dictate entirely new revolutionary security protocols, its operation in the 6 gigahertz band does carry a crucial requirement. It mandates the use of WPA3, and this is a significant step forward for security for basically everyone using that 6 gigahertz band.
WPA3 mandatory on 6 gig.
Okay.
Yeah. So, just to clarify, WPA3, which was introduced back in 2018, offers some much-needed improvements over the older WPA2 standard. Particularly in preventing things like offline dictionary attacks. That's a type of brute force attack where someone captures your Wi-Fi handshake and then tries to crack your password offline. WPA3 makes that much, much harder. Now, don't get me wrong, a properly configured WPA2 network is still pretty robust, especially if you're using long, complex passphrases and AES encryption. But WPA3 is definitely the clear path forward for enhanced security. It just closes some known vulnerabilities.
Good to know. So WPA3 is key.
It is, and interestingly, that multi-link operation MLO feature we talked about earlier It also has a fascinating security angle. It introduces what's called a higher level M address. This address kind of spans across the multiple radios in a single Wi-Fi 7 device. What this allows for is a single set of encryption keys to be used across the different bands simultaneously during an MLO connection. So as your device seamlessly switches between, say, 5 gigahertz and 6 gigahertz using MLO for the best performance, it doesn't need to generate a brand new encryption key for each tiny switch. This saves precious microseconds of latency, which again is vital for those super sensitive VRR and esports applications. And this innovation, it also subtly hints at future possibilities, maybe converged radio access between Wi-Fi and cellular networks down the line, creating more seamless and secure handoffs.
Oh, interesting. So it sounds like Wi-Fi 7 isn't just about making things faster, but also about building a more robust, more efficient, and actually fundamentally more secure wireless foundation for the future. Okay, so given all these benefits and these underlying foundational shifts, how is the market responding? Are we seeing rapid adoption, or are there significant hurdles holding things back?
Oh, the market response has been pretty dramatic. Wi-Fi 7 is experiencing really explosive growth, which indicates strong confidence in its capabilities. While the market was estimated at about USD 1.0 billion in 2023, projections show it skyrocketing to over USD 24 billion by 2030. That's a staggering compound annual growth rate, CAGR, of over 57%.
57% CAGR.
Yeah, it's huge. And this incredible growth, it's largely driven by exactly what we've been talking about, that increasing demand for data-intensive, low-latency applications, particularly with the rapid adoption of the Internet of Things, IoT, and also advancements in Industry 4.0, smart factories, that sort of thing. Geographically, North America and the Asia-Pacific region seem to be leading the charge in market adoption right now.
That growth is undeniable. But it does raise a question, maybe for a more advanced user or a business. Is the industry moving too fast here? Are we creating a situation where consumers or businesses feel pressured to constantly upgrade hardware before they've even fully leveraged the previous generation, like Wi-Fi 6 or 6E? What's the sort of life cycle expectation here, particularly maybe for enterprise deployments?
That's a really fair challenge. And while the outlook is bright, there are definitely hurdles, as you say. Key among them are still the higher costs associated with installing these new Wi-Fi 7 devices. They're more complex, and that translates to a higher price point, at least initially. This can certainly be a barrier for some individuals and especially smaller businesses. Additionally, there's the potential for spectrum congestion, particularly in that shared 6 gigahertz band. While 6 gigahertz offers incredible capacity, if it's not managed properly in dense areas, heavy usage or interference from other nearby networks can still impact performance, which just reinforces why that thoughtful planning is so critical. For enterprises, yeah, the life cycle is typically longer, maybe 5 to 7 years for Wi-Fi infrastructure refresh, but the pressure to adopt new standards for competitive advantage and just to support new applications, employees, or customers' demand is pretty immense, so it's a balancing act.
Right, cost and congestion. And when can you, the listener, expect to see more of this technology readily available, out in the wild, in new devices, maybe in public spaces?
Well, the good news is it's already starting to happen. While the final ratification of the IE 802.11bb standard is still technically expected by the end of 2025, many products based on the draft standards were actually announced way back in 2022, with retail availability starting in early 2023. So routers and some client devices are out there. And importantly, the Wi-Fi Alliance officially launched its Wi-Fi Certified 7 program back in January 2024. That means compatible devices are already starting to get certified and come to market with that official stamp of approval, guaranteeing interoperability and performance based on the standard. Plus, software support is rolling out quickly. It's being integrated into major operating systems like Android 13 and higher, newer Linux kernels, and Windows 11. So your devices, your phones, and laptops will be ready to take advantage of it as the hardware becomes more common.
Okay, so the certification program is key there for ensuring things actually work together properly. Good. Well, today we took a really deep dive into Wi-Fi 7. We went from its blazing speeds and truly innovative features like MLO and preamble puncturing, all the way to the crucial considerations for deployment, for planning, and for security. It seems pretty clear that the future of wireless connectivity isn't just arriving, it's kind of already here. And it promises a truly transformative experience for how we work, play, and connect across our entire digital lives.
Absolutely. This shift to extremely high throughput, EHT, it really is more than just another upgrade. It feels like it's laying the foundational technology for the next generation of immersive digital experiences. The potential for things like truly seamless augmented reality, believable virtual reality, and a properly connected smart ecosystem across our homes and industries. We're only just beginning to scratch the surface of what that will enable. It really moves us closer to a world where network latency is no longer a barrier to imagination or innovation.
A world where latency is no longer a barrier. That's a powerful thought. So as you consider your own network, your own digital landscape, what previously unimaginable possibilities does Wi-Fi 7 now unlock for you? Something to think about. This deep dive was brought to you by Stonefly. And speaking of cutting-edge technology that's designed for the future, Stonefly offers a 100 terabyte immutable and air-gapped SSO NAS for just $8,995. That's a really powerful, secure, and cost-effective solution for your enterprise storage needs, built for today's demanding environments and ready for tomorrow's challenges. You can find out more at stonefly.com.